SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering basic and applied. Today we shall discuss about the cooling tower. In the last class we have talked about the condenser, in fact the role of a condenser in a steam power plant, and we have seen from the discussion that in a condenser we need to circulate coolant, and in most of the cases coolant is water. If we use water as a coolant and that coolant is circulated through the tubes which are placed in a condenser, and that cold water will receive heat from the steam which is or which flows over the tube, then certainly at the outlet of the condenser that coolant which will come out will be having high temperature. Now, question is that coolant can be taken from the nearby lake, pond or river, but it is not always a case that there will be a river or a pond or a lake adjacent to a steam power plant. So, we need to have a special arrangement so that we can reuse the coolant in a cyclic process, and that too even if a lake, pond or river is there, the water temperature at the exit or the cooling that coolant temperature at the exit of the condenser will be so high that environmental constraint will not allow to discharge that water directly into the pond, river or lake. So, even if the water is available in plenty, because of these environmental factors, we need to think for recycling the coolant, so that in the condenser itself it will take some heat from the flowing steam. Upon receiving heat, temperature of the coolant will increase. In another circuit, that coolant will again release heat to another stream, and the device in which heated coolant or hot water will release heat to another stream is conducted or performed is known as cooling tower. So, if we draw the schematic depiction, so just if we draw, this is the condenser, and so this is coolant in and this is coolant out. So, here steam is flowing over the tubes through which that coolant is circulated, and coolant is water. Now, since the temperature of water at the exit here is, if we consider this is T2 and the temperature is T1, certainly T2 is greater than T1, and that was the purpose to reduce this temperature of steam, so that steam will be condensed, and we had seen that in the last class that condensed steam is collected in a basin, and that condensate is pumped back to the boiler via a feed pump. So, now this coolant is again recirculated. As I said you that we really cannot directly discharge this hot water into the nearby lake, pond or river, even if cooling water is readily available and available in plenty. So, what is done here? We need to have another one circuit through which this coolant will be allowed to pass through a special type of heat exchanger, and this coolant temperature is further reduced by circulating air. So, this is air, and this air stream TA2, and this is air temperature is TA1. So, air which is allowed to flow over the tubes through which this hot water is circulated will take away heat, and the coolant temperature will reduce, and that coolant can be further used or can be further taken into the condenser, and process will continue. So, this particular device or component in which, or this is a secondary circuit we can see, this is the device in which this heat exchange takes place. That means, heat transfer from the heated coolant into the air stream, and that is done in a cooling tower. So, cooling tower we can see, cooling tower is basically a heat exchanger in which heat exchange takes place between hot water that comes out from the condenser and air, ambient air is taken. So, this is what we have understood from this discussion. Now, let us discuss. So, we have understood that in a cooling tower essentially we are trying to reduce the temperature of the coolant which has already taken heat from the flowing stream, and the sole purpose is to reuse the coolant instead of discharging directly that heat hot water into the nearby water source. So, this cooling tower is very important even for the low capacity to high capacity power plants. So, the sole purpose is to reduce the water demand, and we can reuse the water. So, the cooling tower, there are two broad classes of cooling tower. One is dry cooling tower, and second category is wet cooling tower. So, in the wet cooling tower, you can understand from the name of these two different types. Wet cooling tower, in which if we can see from this particular circuit that there are two different streams, one is hot water, another is ambient air. Now, if we allow the two streams, if we allow these two different streams to mix or to intimately mix while heat exchange is taking place, then this type of cooling tower is known as wet cooling tower. So, basically in a wet cooling tower, two streams mix intensely. So, in a wet cooling tower, two different streams, that is hot water and air, these two streams mix together intensely, while in a dry cooling tower, as we have discussed in the context of a condenser, that in a dry cooling tower also what is done, this hot water will flow through the tubes while air stream will flow over the tubes. Now, this air flow is sometimes this air flow occurs because of the density difference. In most of the cases, air is allowed to flow by an external agent like fan. So, whatever is the case, there are two different streams in the dry cooling tower. These two different streams do not mix together. So, this is the difference. Two streams do not mix together while they are exchanging heat, and in another case wet cooling tower, these two different streams mix together intensely. Now, this wet cooling tower further can be sub-classified. Now, this particular classification is based on the fact that we have understood whether it is dry cooling tower or wet cooling tower, we need to have a continuous flow of air, and that air flow will reduce the temperature of the hot water. Now, question is, by how can we have the flow of air through this particular device, that is the cooling tower? As I said that air can flow due to density difference, that is due to pressure that is being developed due to the density difference. So, we know that for any flow to occur, there must be a pressure difference, driving force, that is the pressure difference. Now, if the pressure difference is developed due to the density difference, then density difference of the air, of course, the air which would be there inside the cooling tower will be having high temperature. So, density of the cold air, that is the outside air, and density of the hot air, that is the inside air, these two densities are not same. So, it is because of this density difference there will be a pressure difference, and that pressure difference is the driving force to make the flow occur, to make the flow of air occur through this particular device. So, that means in one case we can have flow of air due to density difference, and that is called natural draft cooling tower. In another case, we can have an arrangement so that a fan will allow air to flow over the tubes. So, in case as if we are allowing flow of air by making an arrangement so that external agent, external this device, that is fan, will maintain the airflow, and that type is known as mechanical draft wet cooling tower. So, this is natural draft cooling tower, and another one is mechanical draft cooling tower. So, you can understand that this sub classification is based on the arrangement of airflow. So, this is based on the arrangement of airflow. Further, this mechanical draft cooling tower also can be categorized into two classes. One is, so you can understand that essentially you will be using an external source, external device to make, which will ensure that there will be a continuous flow of air through that cooling tower. So, now depending on the position of that particular device, that external device, that is fan, this mechanical draft cooling tower can be further subclassified into two categories. One is called forced draft, and second category is called induced draft. So, essentially you can understand forced draft like forcefully we are allowing air to flow through the cooling tower, and induced draft, that means air should be inducted into the cooling tower. So, essentially this particular sub classification is based on the positioning of that external device. So, we shall be discussing this later in today's class. So, now coming to the discussion of the special type, that is wet cooling tower. So, wet type cooling tower, what we have understood, that in this particular type two different streams. So, that is cold water and ambient air. So, sorry, hot water and streams are hot water and number 2 is ambient air, right. So, in this particular type these two streams will mix together. Let us now draw the schematic depiction of this particular type, then we shall discuss about the internal arrangement and also the flow processes. So, So, what you can see from the schematic depiction is that, so this is a wet type cooling tower, this hot water distribution system. So, this is basically hot water distribution system. So, this hot water distribution system sprays water over this particular arrangement, and in this particular arrangement we can see a few bars are layered horizontally, and between two consecutive bars there is a gap, and these bars are known as fill. Now, this since this hot water distribution sprays water over this special arrangement that is called fill structure or bars, then the water flows over that structure, and due to gravity water comes down. Now, you can see that there are another type of arrangements through which ambient air is allowed to flow into the cooling tower. So, now if this air will flow like this. So, this is the air flow. So, what we can understand, this special arrangement is known as louvers. So, there are a few louvers, there is a gap through which air comes in to this cooling tower, and air will be allowed to flow in the opposite direction to the water flow, because water will be spread by this hot water distribution system, and this particular arrangement is provided only to ensure that the distribution of the water should be more or less uniform. So, as the water splashes from one field to another field by gravity, that water flow intensely or intimately mix with the air flow which is going in the opposite direction. So, as if water is coming down, so this is water flow, and you know that air is going up. So, this is air flow. So, this is counter flow type arrangement, and when these two streams mix together, heat and mass transfer takes place. So, basically the air which is ambient, which is at ambient temperature, now that air will take heat from the water that is coming down from the top field to the bottom field, and the heat transfer will be there as well as mass transfer will be there, because when ultimately we will be getting the air from the top of the tower. So, this air is hot and moist air, right. So, basically you know that air will receive or absorb heat from the incoming water stream, and when air will be coming out from the cooling tower, that air is now having high temperature, also having moisture content, and that is why it is known as hot and moist air. Now, let us discuss about, as I have mentioned, that heat transfer will be there as well as mass transfer will be there. So, kind of evaporative cooling. Now, when that air will be in contact with the incoming air water stream, water will evaporate, and it is because of this evaporation latent heat will be taken by the from the water itself, and the cooling effect will be more. So, basically that air which is coming out from the ambience is unsaturated air. So, this air is unsaturated air. So, that unsaturated air when comes in contact with the water, water will evaporate, and for this evaporation latent heat will be taken from the water itself, water will reduce heat. So, water will be the water temperature will reduce. So, that water vapor. So, this as water evaporates, that leaves along with the air stream in the form of water vapor. So, as if the air which is coming out eventually at the exit of the tower will be having moisture content. Now, if we say for example, the unsaturated air is coming in, and when unsaturated air will be at the midway in this particular structure, that time air will be saturated upon receiving water vapor. Now, or absorbing water vapor. So, now that saturated air again when will be in contact with the hot air as it moves further up, then air temperature will be more. So, eventually we are getting saturated air, that has already absorbed water vapor, and again that saturated air is going up and up, it is further in contact with the hot water. So, its temperature will increase and eventually will be getting hot and moist air. So, this is basically the heat transfer. So, this is the mechanism. So, you can understand that this heat transfer as well as mass transfer will be there, and as a result of which water temperature will reduce and air temperature will increase. As I said you that air, unsaturated air will be allowed to flow into the tower. So, in this particular arrangement you can see that these two streams are having flow direction which are exactly opposite to water flow is in opposite to the air flow direction. It is also possible that depending on the design, that water flow is always vertically downward due to the gravity. Now, if we allow air to flow in this direction, so this is the air flow. So, instead of having louvers over here, we also can have louvers in this particular section, and air will come into the cooling tower, which is perpendicular to the direction of the water flow. So, this is water flow. So, this particular arrangement is known as counter flow type cooling tower. And this particular type of arrangement is known as cross flow type cooling tower. Of course, wet cooling tower. So, basically it is up to the designer. Now, depending on the design or placing of the louvers, it is possible that these two streams direction can be changed. Now, question is that air flow, unsaturated air, that will be flown into this or blown into this cooling tower. So, this particular air flow, as I said, may be due to the pressure difference, which is due to the density difference created. So, basically the pressure difference that will be developed due to density difference may be the driving force for the air to flow from ambience into the tower, and it will go up, or sometimes maybe because of the requirement we need to have special device, that is fan, and that fan will allow air to flow through the cooling tower. So, let us now discuss about this. So, now coming to this particular type, that natural draft cooling tower or mechanical draft cooling tower, that we have understood that in a natural draft cooling tower. So, if we now coming to this particular classification, natural draft cooling tower. As I said you that the pressure difference is needed to make the flow occur. So, that pressure difference, if that pressure difference is due to the density difference. So, if we consider that is the pressure difference and if that is the rho outside air minus rho inside air into G into H, right. So, this if this is the case where rho outside, that is density of cold outside air, and rho I, that is density of hot inside air, right. So, you can understand that when air will be in contact with water, that air temperature will increase. So, that is the density of the hot air. Now, if we look at this expression, we can understand that this is not very much, and since this is not very much, but still we need to have substantial pressure difference, otherwise there will not be any flow of air. Why? Because you can understand that air has to flow over this particular arrangement or section, wherein that air flow will experience substantial resistance because of this arrangement. So, if we need to overcome that resistance, together with we need to maintain a certain flow rate of air, then this pressure difference will be up to the a particular limit. Now, since this density difference is not very much, because you can understand the density of the cold air and density of the hot air, that density difference is not very much. So, what we need to do in most of this natural cooling tower, natural depth cooling tower, to get a sufficient value of delta P, since if we now write this is delta rho, since delta rho, since this delta rho is not large, so H will be higher for a desert delta P. So, basically height has to be very large, and that is why the natural draft cooling towers are taller, very tall. So, this is the natural draft cooling tower. Now, if we discuss about the mechanical draft cooling tower, this mechanical draft cooling tower, as I had discussed that to maintain the flow of air through the cooling tower, we need to have an external device, and that device will ensure that the flow of air should be continuous. So, the device is basically a fan. So, if we now look at schematically, if this is the cooling tower and this is the hot air stream, this is the hot water stream, and we need to have cold air stream. So, basically this is cold air stream. Now, we can have one fan here, we can have another one fan over here. So, these are basically fan. So, this is also fan. So, now the purpose of having these two fans is to provide adequate airflow through the tower, right, and then heat exchange will occur and the water temperature will reduce and we will be collecting water at the cold water basin, and that water will be pumped back to the condenser. So, this is the circuit. You can understand that in a forced trap cooling tower, as the name implies, we are forcefully allowing air to flow through the tower, and these fans. So, basically in a forced draft, right. So, mechanical draft means through some mechanical arrangement or mechanically we are supplying air through the tower. Now, it may be due to it may be a forced draft configuration in which fans are installed at the lower part of the cooling tower. So, in this case fans are installed at the lower of the cooling tower or base of the cooling tower, at the lower or base of the cooling tower, as if this blower or fan. So, this fan is allowing air to flow through the cooling tower. So, now what are the advantages and disadvantages of this particular type? Let us discuss. You can understand, since these fans are located or installed at the base or at the lower part of the cooling tower, essentially these fans are handling liquid, these fans are handling cold air. Since these fans are handling cold air, the power consumption or the power that will be absorbed, the power that will be absorbed by these fans will be less. So, advantage is fan power is less as it handles cold air, because air that this particular fan is taking air from the ambience and handling cold air, but still there are a few drawbacks. So, what are the drawbacks, or I am writing disadvantages? What are the disadvantages? Now, since we are trying forcefully air to flow through the tower, so that there will be a chance that air will leak from the tower into the ambience again, because we are forcefully trying. So, number one is air leakage. If we go back to this particular arrangement, so as if fans are located here at the lower part of this or base of the cooling tower, and that fan is forcefully allowing air to flow through the tower. So, air leakage will be there, because all these are mechanical components, there will be joints, flanges, etc., and that air will leak through those joints. Now, what would be another disadvantage? So, basically that air is forcefully blown into this through this tower. So, there will be channeling of flow, because the natural tendency of the earth should be to follow a path having less resistance, and that is known as flow channeling. So, this is called flow channeling. Right. So, basically when this air which is having high velocity will flow against the gravity. So, and that too there is a special arrangement that is field structure. So, that air flow, that air will try to follow a path which is having less resistance, and that is known as flow channeling. Number 3, see, this particular fan is taking air from the ambience. So, there will be, or there might be a situation when that fan can still take the hot air, hot and moist air that is coming out from this tower outlet. So, if we use, or if we show the airflow direction. So, this is hot and moist air. Now, chance will be there that this fan will again try to capture this hot and moist air from the ambience and will pass that hot and moist air again into this cooling tower. So, performance will be deteriorated. So, all these things are there, and if I write here, that is can take hot and moist air to be pumped. So, basically this fan is essentially pumping the air, and it can take hot and moist air to be pumped into the tower, So, this chance also will be there. So, these are the this is essentially forced draft wet type cooling tower, and we had discussed about advantage as well as a few disadvantages. Now, coming to the induced draft. Induced draft cooling tower, if we again try to draw the schematic, so this is hot water stream and ambient air, and that is cold water basin. So, what we can see, just I have tried to illustrate the schematic of this particular type. What we can see, this is the fan and this is called induced draft, right. So, what we can see, in this case, instead of having fan at the lower part of the cooling tower, fans or fan is located at the top of the tower. Depending on the requirement, there might be more than one fans. So, you know that this particular fan is inducting air through the louvers into the tower, and this water stream is coming down. So, this hot water will be distributed by this distribution system in the form of a spray. That water will be allowed to flow over the field structure, and this fan will induct air by creating a negative pressure inside the cooling tower. So, what this fan is doing essentially, this fan is creating a negative pressure inside the cooling tower, and that negative pressure is responsible to create a pressure difference between this ambient air and the air which is there inside the cooling tower. So, that pressure difference, so basically ambient air pressure is higher than the pressure inside the cooling tower, that pressure difference is responsible to make this flow of air from outside into the tower and heat transfer will take place. So, in this case we can see that fan is installed at the top of the tower and so this is one important thing. Now, if we write what are the advantages. Number one, you know that since air is now inducted, so always pressure inside the tower is negative. So, there is no chance of having air leakage from inside the tower into the outside. So, basically no leakage of air. Number two is you know that there will not be air leakage, and second thing you know that this induced draft cooling tower, what we can see that there is no possibility of having air to be inducted or hot air to be inducted. So, if we go back to the previous slide, we had seen that this fan you know forced draft fan will or may collect hot water, hot and moist air and again supply that hot and moist air into the tower. But in this case, since this should be always you know inducted, so chance of inducting hot and moist air into the tower will be reduced. So, chance of inducting hot and moist air is less. So, now these two are the advantages. So, now try to figure out what are the disadvantages or disadvantage. Most important disadvantage is that this particular fan is located at the top of the tower. Essentially, this fan is now handling with you know hot and moist air, and hence you know the power consumption will be more because the large amount of air. So, you know because of this density you know reduction, the volume of air that will be handled by this particular fan is more, and hence electrical power consumption will be more. So, number one, more. Number two is you know that since more volume of air will be handled by this type of fan, the diameter of the fan would be more. So, fan diameter will be large. So, fan diameter will be large because this particular fan is handling or this particular fan has to handle with large volume of air. So, these are the advantage you know these are the advantages and disadvantages. So, now coming to so if we go back to the previous slide, we have discussed about wet cooling tower, we have discussed about both natural draft and mechanical draft cooling tower, we have also discussed about forced draft and induced draft cooling tower. So, now let us discuss about dry cooling tower. So, dry cooling tower. As I said that in this particular type two different streams do not mix together. Instead, heat transfer or heat exchange will takes place while one stream is passing through the tube or tubes and another stream will pass over the tubes. So, if we try if we try to understand the mechanism of this heat transfer, it would be convenient if we discuss it with a schematic. So, so this is the schematic depiction of a dry type cooling tower. So, what you can understand is that steam from or which is collected in the steam drum. So, at the exit of the turbine, that steam is now so the steam is in the condenser. So, at the exit of the turbine, the steam drum is there, steam is collected, and that is the condenser that we have discussed. Now, that steam is allowed to flow through a number of tubes, to be precise fin tubes that we can see. So, all these are fin tube. So, all these are the fin tubes, and as you can see that steam is coming from steam drum through these tubes which are fin tubes, and this is basically fan. Air is allowed to flow over this fin tube, and this flow is initiated by this fan. So, basically what we can understand is from this particular arrangement is that that flowing steam, so basically this is the steam flow, and we will be having air flow. Also fin tubes are fin tubes. So, to have more heat transfer. Now, this flowing steam is cooled by the air blown over the tubes by this particular fan. So, you can understand this is a forced draft fan. Steam which is coming out from the steam drum into this fin tubes, that steam is cooled by the air which is blown over the tubes by this FD fan. So, this is the arrangement. Now, try to understand, since this is not basically that these two streams are not getting mixed intensely. So, mixing efficiency or heat transfer efficiency will be poor, and if the heat transfer efficiency is poor, that means steam temperature, I mean the temperature of the condensed steam will be little high. If the condensed or condensate, because essentially you will be collecting cold water, that means the condensate, and that water will be this water. So, this is I should write so this condensate will be collected and pumped back to the boiler by the pump. Now, since the condensate that will be collected here, because of this I mean the heat exchange efficiency is not that much efficient, the temperature of the condensate will be little more, and that will increase the turbine back pressure. If the turbine back pressure is more, we have discussed in the last class that specific work output will be less and it will reduce the plant efficiency. So, dry cooling tower, this particular cooling tower is most I can say promisingly used in places where water quantity is less. So, basically used in places where water is not available in plenty. So, this is the advantage. Now, disadvantage is heat exchange is not efficient so turbine back pressure will be more, that means lesser cycle efficiency. So, that means the cycle or plant efficiency will be less, because the temperature of the condensate would be little more, which in turn will allow the turbine back pressure to be high. And we can, if we recall the discussion that we had in the last class, that specific work output of the plant or cycle will be less. So, these are the advantage and disadvantages of this particular type of cooling tower. But still this particular type of cooling tower having all these disadvantageous feature, this particular features, this particular cooling tower is or has promising potential to be used in places where water is not available in plenty. So, now if we summarize, we have discussed about the cooling tower today, we have tried to understand the role of cooling tower, then we have discussed about the classification of cooling tower, and for each type we have analyzed the mechanism of the heat transfer. Together with we have discussed the merits and demerits associated with each type. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.